Introduction, Materials, and Procedure. Students will use a marble launcher to launch a marble or ball bearing into the air at a 90-degree angle to the floor. In other words, we're launching it vertically. We're going to use the word marble for the rest of these instructions. Students must first pull the handle of the launcher down, which will give the system elastic potential energy, and when you release it, the elastic potential energy will be converted into kinetic energy, giving the object an initial velocity v. When the marble reaches the top of its trajectory, which we're going to call h, all of the Ke is converted into GPE. Here's our list of materials. We have a marble launcher, and its different types, a 10 or 20 gram ball bearing or marble, a meter stick, a scale to measure the mass of the projectile, and, this is in bold, safety goggles. The following items should be prepared before the students arrive. Set the marble launcher at a 90-degree angle with respect to the floor. It's another way of saying have it pointing straight up. Set up the scale to measure the projectile's mass. Place the meter stick and projectile, which is either a marble or a ball bearing, near the other materials for use. Have safety goggles available for all students and yourself. Here's the student's procedure. Before any marbles are put into any launcher, all students and the teacher must put on safety goggles. And here's the procedure. Measure the mass of the marble and record this in the data table at the back of the handout. Set up the marble launcher so the marble is launched vertically into the air, and hopefully the teacher's already done this, but the students can certainly check it. Holding meter stick vertically level with the middle of the marble, ready to measure the maximum height of the marble's trajectory. And with the marble in the barrel of the launcher, place the handle of the launcher into the first notch, the shortest compression of the spring. Release the handle, which will launch the marble upward. Measure how high it goes. Record this height in the first data collection table. Repeat the launch 2 more times so that you have recorded 3 heights for the first notch. Repeat steps 4 through 6 for the second and third notches on the launcher. You will now have 3 heights measured for each of the 3 notches, so that's 9 measurements. Finally, for each of the 3 notches, measure how much the spring is compressed. Okay, that's not how high the marble goes. It's if you had your spring like this in the beginning, and then when it compresses like this, we want this distance here, okay? Record the compression, X, in the data analysis table. Warnings for the lab. Wear protective eyewear in order to avoid eye injury. Do not look directly into the launcher barrel. Assume every launcher is loaded and treat them with care. If you are not sure of a launcher status, ask the teacher for help. Do not put your fingers into the barrel of a launcher. The teacher will use a pencil or rod to clear any launchers. Tie long hair back so it doesn't get caught in the spring of the launcher. Do not point the launcher or shoot marbles at others. Good grief. Serious eye damage can occur if a marble hits your eye. When marbles hit the floor, they tend to roll away. Have students keep a close eye on the marbles so they are not lost. Here's a sample of the data collection tables. You can see we have 3 setups, 3 different spring settings, 3 different notches, 3 trials for each one, and you record the height here. And please make sure to do it in meters. Meters, we always deal with meters. And then you take the average right here of each notch. Here's your data analysis table. Here are your measurements, right here. And then here's your calculations where we begin analyzing the data.